Focal background.
Hi, everyone. Welcome to our webinar today on securely leveraging LLMs in enterprises. My name is Mary Kirshner. I lead customer success team here at FocalCXM, and we are very happy that you're here with us today. Before we dive in, I'd like to mention that there will be dedicated time at the end of our session to address any questions or comments that you might have. Please feel free to submit your questions using the Q&A link below, and we'll make sure to cover them during this discussion. Today, we'll explore the world of large language models and discuss how enterprises can leverage their potential while maintaining strong security measures. We are very happy to have Srini Alluri with us today to lead that discussion. Srini is Focal's CIO and has experience and passion for LLMs and their capabilities. He's led many projects across multiple industries and is eager to share his knowledge with all of us today. Thank you for being here today, Srini. I'll pass this on to you.
Yeah, thanks, Mary. Thanks for the wonderful introduction. Hi, all. Today, we are going to discuss about how do you securely leverage LLMs. As we all know that with the advent of LLMs, the market has opened up for unforeseen opportunities. So with the opportunity comes the risk. Now we are going to talk about how do we securely leverage LLMs. So to begin with, right, the agenda goes like this. We'll talk about briefly what is a large language model, what is the backbone for that. Then we would talk about the challenges and risk involved while you leverage LLMs. Then comes the most interesting thing for today, which is how do you securely leverage LLMs, followed by one very interesting use case, which is a real-time use case that we are going to present. Having said that, we'll begin the webinar. All right, so we all know what the magic an LLM can do. However, just a technical deep dive into what constitutes an LLM. LLM primarily constitutes of these 6 modules or components, primarily starting with tokenization. What it means in simpler terms is LLMs are text-based models which understand text, and probably they do forecasting, summarization, all this. But how does they do? So there are multiple modules involved, right? So primarily starting with tokenization. It takes text, and tokenization would basically divide text into small chunks. And these smaller chunks are basically converted into a mathematical representation called a vector, and typically through an embedding model. And once we have the embeddings, basically the positional encoders are responsible to tag the data. And then in LLMs, something is determined which is called an attention. Attention is a methodology where you establish relationship between 2 words, to keep it simple. Then after you establish this, then LLMs go through pre-training. And then LLMs are very famous for transfer learning. What does it mean is LLMs don't require you to retrain anything. There are various methodologies using which you can minimize the cost to retrain the model. And finally, this is the end application, which is LLMs are used for generative use cases. So after this brief introduction into what constitutes an LLM, we'll quickly move on to a little more deeper. What is LLM made out of? While those components are there, LLM primarily uses transformers, which are the backbone of LLM. And these transformer models ideally are responsible for encoding and decoding of the text data. And ideally, this is the vector representation what we're talking about. If you see, to the left is the input, to the right is the output in vector representation. What we can easily identify is similar words are being grouped together, which means there's a relationship. So that is how the transformer works. So this is an oversimplified explanation of what a transformer framework is all about. Moving on. Yeah. So now we know that LLM exists. So what are the typical challenges or limitations that you have for an LLM model? So because pretty much in every industry and every organization, LLM is getting leverage in one way or the other. However, there has to be a deep attention towards what are the challenges that you could face, especially in terms of security and trust. So that is going to be the topic of discussion for today. So LLM typically has limitations in terms of computation capacity that it needs. Then obviously it is dependent on data and the data privacy. then the kind of our responses from LLMs, if you're highly dependent on that, then the over reliance on the outcome of LLMs could be a risk. Then how do you ensure that the LLM inputs and outputs are complying to your regulatory needs? So these are the typical challenges. We will not deep dive into every aspect of this today, but we'll primarily focus on how do you ensure that the data privacy is being achieved while you leverage LLM. At the same time, how do you comply to regulatory needs of your organization, especially enterprises? Okay. So what does robust security look like for LLM? So we have come from a world where we have seen a Java program security, right? So we have a Java program. How do you ensure that Java program is safe, right, from your OWASP vulnerabilities, or it could be any other challenges where it could eat up memory and crash. So similarly, considering even though the LLM is highly complicated and integrate, the same principles of security apply for LLM as well. However, the aspects of security would slightly vary, and the kind of controls you exercise on LLM security would differ. So primarily, there are 4 pillars for LLM security. We'll start from the most important thing which is data. So LLMs are pre-trained. For example, all your general purpose LLMs like Llama or your ChatGPT, all these LLMs are trained on public data. But when it comes to enterprises, those LLMs are not really helpful, primarily because they are unaware of your enterprise data. So how do you leverage an LLM in a useful and meaningful way to solve your enterprise challenges? Begins with giving the right information to the LLM so that you get the expected outcomes. Example could be, if an LLM, assume that the LLM is trained on your enterprise data, and now you ask summarization of your, let's say, sales data of your enterprise, it would happily give you back an answer. But what do we see is it as a risk that you're training it on data, and data is private to your organization. So how do you protect your data? So fundamentally, the data protection starts with anonymity. What we mean by that is whatever data you consider as sensitive in your dataset, probably your customer PI information, all that has to be masked before you train your LLM. At the same time, you have to maintain relational integrity. That's the second challenge you got to solve. Then whatever data is being used as part of your interaction with LLMs, that data has to be encrypted during rest. At the same time, it has to be encrypted during transit. So there are a couple of algorithms which are general purpose algorithms we mentioned here, which can be used for the same purpose. Then the other thing that we can do is there's a principle called differential privacy. What happens here is you have a data set. However, you can introduce some random noise into the data set so that when somebody gets a handle on your data set, they might not understand the data set as such. So that still, even though after the data is being compromised, your data is still protected in a way. Okay? So while we do this data protection, then comes how do you access your model, right? So LLM is again access like any other business. I mean, you have microservices in the past. So typically, when you want to access an LLM, you will access it through an API. So naturally, because it is an API, it has to be protected with the right design principles. So first of all, we'll protect your API using the right security keys. Then we do tokenization in the sense, whatever data you're passing to the LLM, it is not a meaningful data. You check the data, tokenize it, and send it. So even though somebody intercepts your data on the fly and try to read the data, they wouldn't make any sense out of it. Then since it is an API, again, any LLM API, you can put a rate limit so that you know if somebody is trying to bombard with messages, try to bring down your system. Right. So this is how you principally secure your model, which is deployed. Then the next important thing comes is you have an LLM. From LLM, you're accessing it. The LLM is getting access using an API. However, the API is not directly accessed, right? You need an interface. It could be an omni-channel interface. It could be through a website. It could be through a mobile app, or there could be various means in which the API can be integrated. So what happens here is, again, the fundamentals come into play. The access that you give to these omni-channel interfaces has to follow these principles where you have role-based access, and then you follow the principle of least privilege, which means only needed things are given access, not like you give few things just for privilege. And then there could be other mechanisms like MFAs, which may or may not be falling under your purview. Then the last principle or the last pillar is monitoring and auditing. This is extremely important. What happens is in LLM world, there could be prompts which are trying to steal information. The prompts can be curated if you're not managing your API properly. So the data can sneak in directly into your LLM, and then the prompt's response could be very different, right? So you have to monitor and evaluate. So what we mean by that is, we have another slide on the technical architecture, but at a high level, you have to monitor your input, monitor your output before it getting passed to the actual response in your UIs. So this monitoring and auditing tools are extremely important. You monitor the performance, you monitor the prompts, you monitor the veracity of information that is passing in and passing out of your LLM. So having said that, these are the four primary pillars where we have to focus while leveraging an LLM. While LLM is the last mile in the whole ecosystem, what you're talking about, or in the workflow, but we should start from the very beginning, which is your data, right? So interesting. Now we'll move on to the next topic, which is, yes, we spoke about the pillars. Now, how do I implement it? Now we are talking from guidelines to implementation. So when it comes to implementation, there are actually three architectural patterns that are generally called out in the market, but I would still call them as they can go hand in hand as well. It's not that you use one, you cannot use other. So we'll begin with the most famous one, which is RAG. So it is retrieved augmented generation, which is very famous, and it has got multiple variants as well. We'll come to that in a minute. Then comes your infrastructure. Architecturally, how secure is your infrastructure so that it is protecting your LLM, which is expected to be hosted in your private environment, right? Then comes federated learning. So everything gets through data, and how do you train data? So federated learning is an architectural pattern or a practice using which you train your LLM. So you can use this and this separately. If you're using this, you may use this, but this is mandatory. So that's why I kept it to the right, where infrastructure security is mandatory. So first we'll talk about briefly how RAG is enabling you to secure your LLM. All right. So for an easier understanding, we have put together this flow. So in a typical RAG architecture, what happens is, imagine a web application and the user is giving a question, or a chatbot for that matter. So whenever a question is being used, an algorithm will convert that question into an embedding. Embedding, if you remember, fundamentally is a mathematical notation of a chunked text, right? And then we call it query embedding. And we have something called a vector DB. A vector DB is, again, like any other database. For example, you have SQL databases where you store data, numbers, and all that. Vector database is primarily designed for storing embeddings, which are chunks of data, chunks of text data to be precise. So what is this doing here? We have an embedding. So it looks up into the vector DB. An analogy to what happens in SQL. Let's say in SQL, you're making a query to identify a company's name. I mean, what is the richest company in India? You get, let's say, Reliance, and then you got a string. So here, it is a query embedding. So what you get as an outcome is a relevant chunk data. This is not human readable. So that is the beauty of it from a data security perspective. So you got relevant chunks. Then what happens is you combine the actual question and the relevant chunks. These chunks can be in the form of documents as well. So what are we trying to do here? So we are trying to create a context. Why do you have to create a context? Because your LLM is unaware of your enterprise data. So whatever you're seeing on the left is the mechanism through which you are making sure that LLM is understanding what you're asking for. And how is it possible? It is possible through creating this context. This context was constituted of chunks from your vector DB. It constitutes of the documents which are being used to create this chunks. So that is what the that is what the context constitutes of. And when you pass this to LLM, it does the completion. Completion is nothing but the LLM understands this, it understands your query, it understands the context, and accordingly it'll give the response. Again, warranting that this response is purely dependent on how efficient is your context, right? Because LLM was never aware of your enterprise search data. What is the advantage of RAG? right? Here, evidently, there are three advantages. One, you have never trained your LLM on enterprise search data, but yet you are getting a chance to leverage the power of an LLM and get the right outcomes what your business is expecting. So primarily three things when you implement RAG architecture. One, you provide up-to-date and accurate responses. Why? Because you're creating the context. Two, LLMs in general, when they are not aware of the complete context and it was not historically trained on that data, then it turns out to give something called hallucinations, which means the information is fabricated or imagined, right? With the RAG architecture, you can minimize the hallucinations. The third thing, which is extremely important, is efficient and cost effective. This is typically pertinent to your infrastructure needs. For example, if you have to have your, I'll talk in the other architecture, we'll talk about it, where if I have to train my LLM on the enterprise search data, it incurs first lot of compute power and storage power. Two, lots and lots of data for it to understand what kind of data it is and what kind of patterns there are available among the data. All to determine all this, it needs huge amount of data. Third thing, for if you interact with LLM directly, there is no layer which is typically understanding the input and trying to filter out if there are from a compliance and regulatory needs. So with RAG, you're able to accomplish every single thing what we spoke about. So that is why RAG is the most successful frameworks which is used to securely interact with LLMs, right? So that's about the RAG. Moving on. This slide talks about how you can securely leverage a LLM model which is either installed on-premise or on cloud. So each one of them has got pros and cons. For example, data security, if it is on cloud, obviously a data transfer is needed out of your network. That is risky. That's the con of cloud-based here in data control. When it comes to compliance and regulatory, if you see on-premise, you have to implement every single control on your own. But if it is a cloud-based, let's say an LLM should be compliant with HIPAA. If we go to AWS is a cloud service provider for your organization. You can just spin off an HIPAA compliant AWS cloud. So then moving on to infrastructure security, more or less again, a cloud-based has got their own services to implement the security. For example, their firewalls, their subnets and all are available as services here. However, if it goes to on-premise, you have to orchestrate the services. Then last but not the least, extremely important choice that you have to make is the scalability and cost. When it comes to cloud-based, it's on demand, as we all know. Typically, the scaling of the servers and all is pretty much taken care by framework like SageMaker and all. But when it comes to on-premise, if you have to provide that kind of infrastructure, scalable infrastructure, then there will be a lot of upfront cost investment that has to happen here. That's the downside of on-premise. So again, based on your compliance and regulatory needs of your organization, and then where you already have invested into. For example, let's say your organization already invested on-premise, then try to leverage the best out of it. But bottom line is, it has to be adhering to the security principles. That's the key. Okay. All right. Now, coming to another very interesting architectural pattern of implementing LLM, right? So far we saw RAG, and we also discussed about the choice between on-prem and the cloud services. There's something called federated learning. In simpler terms, what happens is, if I have to leverage an LLM and it has to work seamlessly, then the LLM has to know enterprise data. In that scenario, a centralized database is created. The data is dumped from from multiple sources, and then LLM gets trained for probably multiple months and then undergoes a lot of fine tuning. There are two downsides to it. One, in this, it is pretty much sequential in the sense, I have a centralized database, I have an LLM, and you're training it. As in, if the data is huge, the time is proportionate to that. So in 2017, Google has tried out this innovative framework of federated learning in the machine learning world. What it did is, It has tried to decentralize. So in contrast to centralized training, they come up with the kind of concept of federated learning, which is decentralized. What happens here is, one, you have data decentralized, and you have your models trained on each data set separately. Let's say there are 10 data sets. I would have 10 models, but they are derived from my base model, and whatever the outcome, I'll aggregate it and push it to my centralized model. Here, this is called horizontal federation. When it comes to vertical federation, the data is there, but whatever features are there on the model, they would be chunked. In the sense, let's say the model has 50 features. Now probably I'll take 10 features each and then train. This is vertical federation. The third one, which is interesting, is transferred federation, transferred learning federation. In here, what happens is, primarily the model would have been pre-trained, but what you do is you will have a very specific need. So you take only specific subset of data and train only on specific tasks to cut down the amount of time investment, the amount of cost involved in terms of infrastructure. So this is the third pattern that can be used. Overall, federated learning is again a security architecture pattern while implementing LLMs. So one was RAG, where you don't care about the data. Here, you don't care about the RAG principles, but you care about the data, and you don't want any additional overhead of vector databases and all. So you come into this model, you take the base model and use whatever pattern suits you. What do you accomplish here? One, 100% data privacy and reduced attack on the surface, because the data cannot be compromised so easily because it is decentralized. And whenever you're training, you can still encrypt and decrypt data when the data is in transit or at rest. And then finally, there is differential privacy, which techniques that can be applied so that your model is safe and your data cannot be compromised. So this is the third architectural principle, very powerful. And truly there is no either this or that. They can even be combined. For example, you can use RAG, but still you would have trained your base model with one of these techniques for more efficiency reasons. So we spoke about the architectural patterns, how you can secure your LLMs. Now, what is the end goal, right? So we know the LLM, we know the how to implement LLM. Now, LLM has to be part of my enterprise workflow, which means there has to be a meaningful way of leveraging the power of LLM, right? So these are the top 5 use cases what I've picked up from the collateral available. So fundamentally, it is information retrieval with a plethora of data. What you have out there, you can simply implement an LLM to retrieve data meaningfully and contextually, or you can use there's a use case of sentiment analysis. For example, it could be emotion detection or business insights from the data available. Text generation, obviously, I think a lot of us have been using ChatGPT. We don't have to speak about it. Code generation, as developers, we know what is the power of this. Then finally, chatbots and conversational AIs are catching up speed, because traditional chatbots are like very mechanical in the sense in their responses. It's like Q&A. But with LLMs, right, the chatbots have become more inclusive in terms of how we interact with them. They give that human touch. That is very a phenomenal change in terms of how chatbots have evolved, which are backed up by LLMs. So among all these, once you implement the LLM securely, then these are few best practices. Obviously, you have to keep training your LLM. If you're not training it, then obviously you have to have a right RAG architecture with a vector DB in place, which is secured. You have to fine-tune your LLM. There are, again, multiple fine-tuning techniques just to make sure that security is not just to secure your LLM, right? Security would also mean that, are your responses correct? Are your responses accurate, right? So that is what fine-tuning plays a big role in terms of how compliant are your responses. And then this is extremely important given where LLMs are today and how AI agentic framework is evolving. So even though there are a lot of agentic frameworks bombarding, this becomes inevitable in a lot of cases, in the sense there has to be a human in the loop when you're taking critical decisions. LLMs can give you an outcomes. LLMs can give you, along with frameworks, LLMs can give you a decision, but whether that decision has to be taken or not, most of the cases, especially in regulated industries like healthcare and life sciences industries, a human intervention is needed. So that is why this is a very powerful component of your enterprise implementations. Then performance monitoring, yes, this is, I think, no-brainer. Your LLM should be performing. Again, it comes at a cost. Feedback, or the performance of LLM, especially when it comes to security, your feedback loop should be powerful to whenever it identifies an incident which is security incident, that has to be immediately reported back, stating that what is the nature of security incident and how do you classify it, what is the mitigation strategy, all that has to be taken care of as per your SLAs. So these are a couple of best practices. And then I just want to spend a couple of more minutes on something called an interesting topic about automation and augmentation. So as engineers, we all know that automation is something which is powerful. We have been automating processes, automating business flows. We had workflows being automated. All automation is there for a long, long time. And then came the robotic process automation. With LLMs, yes, obviously, there is a greater degree of automation. It's not automation in per se as a workflow, but automation in terms of the response. In the sense, if I have to curate the same response using the existing tools without LLM, probably it would have been taking 20 to 30 steps with NLP processing and the augmentation and all that. So it has simplified it. However, the outcomes of LLMs should have guardrails, which means you can do an augmentation, which means the LLMs are helping a person. It's not that LLM is actually automating the role of that person. Simple example could be if there is a clinical study report that we can easily generate today using an LLM and the aided technologies around, but is that clinical study report sufficient enough to be submitted to an FDA is not a decision that an LLM can make today, right? We are not there yet. So where I'm alluding to is, while you can achieve most of the automation and human-like responses from LLMs, we always should have a human oversight wherever there are high-stake decisions, right? And then we always have to strike a balance between what can be automated, what cannot be automated. And we should have right controls like validation of input, validation of output, checking against the compliance standards. All that should strike a balance there. Fail-safe mechanisms, obviously, if the responses are hallucinated from an LLM, how do you ensure that your system would automatically recover from them and try to provide more meaningful context to the LLM to provide a meaningful outcome, right? Transparency in decisions. This is basically talks about how your AI models are allowing humans to understand and validate, right? The decisions have to be validated. And then scalability and control, obviously, wherever humans are involved, naturally there are systems with which you interact, so those systems should be scalable securely. So that is the difference between augmentation and automation. Automation, a system will take a decision. Augmentation, a human is given enough information by the system and they'll take a decision. All right. Having said that, now I believe this is the time to look into a real-time use case, what we have taken up as FocalCXM. As we mentioned, FocalCXM is a software company primarily focused on life sciences industry. So this use case, what we are going to showcase here is a problem statement in life sciences industry. Just to give a quick background, medical information specialist in life sciences industry, their job is if a drug is being consumed, let's say by a patient, and he's got some side effects, he would call up a doctor and say, hey, you prescribed this and I got some side effects. Then the doctor, based on his knowledge on the product, could immediately respond to the patient, or what he can do is he'll file something called a medical information request to the company, right? So in this case, what happens, there is a chain of events. The patient is talking to the doctor, the doctor has filed a medical information request. Now, as compliance, and the bare minimum need here is the medical information specialist has to comply to two KPIs. One, the time at which he has to respond. to the efficacy of information he has to respond with, right? This could be a simple ecosystem, how the use case could be, which means there's a business administrator who is determining, okay, these are the KPIs for this MIR. Then medical information specialist is trying to look up for multiple systems to look up for the data and share it with the doctor. And now this is where the new extended arm of medical information specialist came in, which is AI engine, which primarily leverages LLM to respond. So we'll go a little deeper. So the way we'll start this is just a framework for any use case, right? So we'll start with ideation, and then from there we'll implement it. So in this case, for this next gen search platform was the solution that we provided for the medical information specialist. What it means is this medical information specialist could seamlessly search across a variety of databases in one single click, and AI in the backend is enabling them to be more efficient, one in terms of the turnaround time, two in terms of the efficacy of the information. How did we accomplish this? This is a snapshot of our technical architecture. To the right, you see it's all logged, which means it's all secured. The data is secured. It's all on, be it on-premise or be it cloud. If it is cloud, we use VPCs, firewalls, and every single control that is needed to keep the data secure. So once the data comes, by principle of the RAG architecture, we use RAG architecture here. So we have split the data, and the data is stored in the vector DB. Again, the vector DB is hosted in a VPC, which is secure. Then there is a web application that is hosted for the end customer. The end customer would come in, would key in a query, and this query is going for a validation. So this is where the security is kicking off, right? So we are validating the query. If the query constitutes of some special characters, some non-compliant keywords, everything is validated. And the query is not a valid query, then we would eliminate it. If the query is valid, then it would be passed further. What are we doing here? Then we are taking this query. We'll do a semantic search in the vector database. We'll retrieve the relevant documents. So it is a combination of your, again, vectors plus the documents, and then we are passing it to a QA chain, and LLM is part of this QA chain. So LLM itself is not the model here. There is a chain that operates. LLM is part of it. Then what is the outcome? We'll get a summarization. At the same time, we are also using keyword extractor from the query, and we are giving a response, which is basically summarization plus keyword result plus relevant results. So there are multiple things that you can do. And ultimately, the response is again validated for security reasons. And finally, once it passes all security checks, which means the validations and compliances that we introduced, and every enterprise can have their own validations and checks, which can be implemented as part of this chain. Once that is done, then the outcomes are displayed to the valid outcomes are displayed to the end customer. So this is how we have implemented an LLM, leveraged an LLM to solve a business case problem of medical information specialist retrieving data in order to respond to the MIRs filed, medical information requests. All right. So this is the background of how we implemented a use case. Now, we would like to give a quick demo and give you an experience of how this would work. So if you allow me, I would just slip it. Okay. All right. So this is the enterprise search platform, what we have implemented at Focal. And so what it means is here, these are all the data sources that are connected, which means we connected to that respective data source. For example, the data could be it is by named meaningfully. However, it could be like a SQL database, it could be an S3, it could be anything, right? So in the MIR use case, what you're talking about, we are interested in two things. One is what is adverse event data and clinical study data. So the user can come in here, and there are two ways using which you can interact. One through the search bar, the other through this, right, which is chatbot. I'll try to key in some questions in order to understand how the system would respond. So these are all human-like responses that would come in. So I'll try to leverage these questions. Right. So I'm coming to my enterprise search, and then I'll keep here for reference. So let's say I'm taking this example of what are the key issues with this drug, basically. And then I click on search. In the backend, what the system is doing is typically it is going against these two databases, and it is trying to give you the results. So let me show you this. So if you see here, it identified this particular clinical study related to this particular drug. And then if you go to all here, and then I give a question, give a summary here. So based on the source, the data is segregated. All means it is doing a lookup for across all the data sources that are being configured, right? So there is nothing specifically present in rest of the data sources. However, these two data sources, they have the data. So that's how you see this here. Now, when I go to this chatbot, and if your backend data is ready, then the chatbot would give you an answer related to this drug. So in the backend, what's happening? There's an LLM that is being leveraged. There's RAG architecture that is being leveraged. So if you see this, for this question, there is a beautiful, meaningful answer that is being retrieved from the chatbot. So this is a very simplistic use case. It can get as complex as summarization, as complex as semantic search, relevant search. But bottom line, the power of LLMs is tremendous, right? But with great power, there comes great responsibility. So they have to be secured and they have to be safe. So we discussed about how do we do it very briefly, but we are in the world where trends are changing very frequently. So we need to be aware of the kinds of threats that can happen. So it's a continuous journey for all of us to make sure that our systems are safe and secure. Having said that, that is the content I had for today. Thank you all. Thanks for joining. And I'll keep the forum open for questions. Thank you.
All right. Thank you, Srini, for your informative and insightful presentation. That was wonderful. We do have a couple of questions here, and I think we have a few more minutes left in our time, so we'll get to these right away. The first is, what is the biggest security risk that we encounter while leveraging an LLM?
The biggest security risk is if you're not validating the prompts that you're giving to LLMs, you might end up giving sensitive information back. So whatever input questions you're giving, you need to have a mechanism to validate whether that is allowed or not. That's where your governance and compliance would come into play.
Okay, great. Thank you. The second is, are there any limitations in RAG architecture?
Yes. So like the framework is beautiful. However, as your data grows, the size of your vector DB grows. And because the size of vector DB is huge, now your response times would be slower. Or if the data is not right in your vector DB, you don't have enough data, then the outcomes that you create in the context could also be meaningless. So I think these are the two things which you have to take care in the RAG architecture.
Okay, thank you. Is there any significant advantage that we get with federated learning?
Yes. The significant advantage that you get is with federated learning is if you don't want to invest your time and energy in building the RAG architecture, managing vector databases and all, the simplistic way could be you use a federated training such as transfer learning, and train your LLM specific task by task. That way, only subset of data get exposed, and obviously it is encrypted by design. So that way you avoid any data breaches. At the same time, you would save on your computational capacity, and turnaround time could be very fast.
Great, thank you. One final question. What is the LLM that you used for implementing the MIS use case?
Yeah, it is Llama 3 to be precise.
All right, I think that is it for today. Well, thank you all for joining us. We will be able to find this link to the webinar on our website, and we look forward to connecting with all of you. Thanks again, Srini.
Thank you all. Thanks for joining. Have a good day.